And it's my absolute pleasure to introduce this afternoon Andriy, who's going to talk on advances in carbon conductive additives for LIB applications. So over to you, Andriy.
Thank you, Chris, for the lovely introduction, and good morning, good evening, good afternoon, folks on the call. So let me jump to my sort of outline for the talk. So I will start first, just mention a few words about Cabot in general, and then Cabot battery material business, and then touch on some of the problems that may sort of associated with the conductive additive on the cell level, on the slurry level, on the electrode level, and kind of finish up with the sort of two most recent developments. One for the commercial launch of one of our conductive multi-volt CNTs for the cathode side, and some interesting results we are getting with what we call carbon nanostructures. So this is sort of a unique new type of conductive additives, and this is specifically designed for the sort of silicon anode side. So with that, let me transition to, oops, too fast. Let me transition to Cabot glance slide. So perhaps some of you may know Cabot is it's a quite old, 140 years old company. We headquartered in Boston. We have about truly global company. We are operating in many countries. We have 45 commercial plants, in 20 different countries. A very strong commitment right now, obviously, to sustainability. And over the years, develop a portfolio of additives, solutions to address some of the customer problems. So obviously, we are essentially a particle engineering company. So we do have a lot of expertise in these areas. And of course, I'm not going to be talk about sort of particles for tires, which is probably where sort of the Cabot name very often associated with, but I will kind of more focus on the performance chemicals, where it's essentially collections of various businesses not related to the reinforcement of tires. And of course, battery is one of them. So let me jump to the next slide and talk a little bit about specifically kind of Cabot battery material business. So in our battery material network, essentially we have 4 commercial plants which makes conductive carbon blacks specifically for lithium-ion battery cathode and anodes. And 2 of them, hopefully you see the pictures, is in US, one is in Europe, and 2 more in China. We also have one plant fully dedicated to manufacturing of the conductive carbon nanotubes and dispersions comprising those tubes. And of course, we are always happy to support our customers so we have 6 commercial and technical support centers across the globe and 3 R&D centers. So today I'm calling from our center in Billerica in Massachusetts. So with that, let me kind of transition and talk a little bit about conductive additives. Of course, I'm sure folks are familiar on the call with the conductive carbon blacks or conductive carbon nanotubes. And of course, the primary function of those materials, why you want to add them into your cathodes, for example, is to obviously to increase conductivity to a desired level. And so if you look at, sort of this commercial, basically this ICM pictures of the cathode, you can hopefully clearly see sort of one of our conductive carbon black product called Litix HP with NCM 622 cathode. And you can see the small particles essentially, which is roughly the size of about 100 to 200 nanometers. So kind of you can, schematically it's kind of shown here. They sort of comprise of the aggregate with a bunch of small primary particles that fuse together. And so because of sort of that morphology, obviously they have a lot of contact points, they're conductive, so they basically very effectively distribute the field, and as a result of that, basically make your electrode, reaching the desired conductivity. So the carbon nanotubes, on the other hand, is of course